All right, I think we're ready to get started. So tonight, well, first of all, welcome back, or welcome if it's your first time. This is our second ever AWS South Bay Meetup, or user group, or whatever it is that we called it. Excited to see a lot of new faces and a lot of the same people back as well. Tonight we're going to be talking about serverless, which is one of the top topics that people were asking to hear about. So hopefully you'll learn something new tonight. And first, just introductions. My name is Jonathan LaCour. I'm the CTO of Reliam, and also now Stratalux, which we just merged with as of last week. So there's a lot of Stratalux people here and Reliam people here as well. We are an AWS consulting partner and managed service provider together. Now we're a bigger one of those, which is pretty exciting. I'm a technologist and programmer. My background is in engineering. I like writing code. I also enjoy bourbon a lot, but I'm currently on a 30-day fast, so I'm not enjoying that very much. Yeah, nice to meet you all.
Hello, everyone. My name is Lance. I'm a cloud consultant at Reliam.
A senior cloud consultant.
Senior cloud consultant. Watch out. I tried for a very long time to find a cool picture of me like Jonathan in a suit, and then I gave up because I'm a family man, and this is my typical weekend right there, going to the park with my kids.
Rugged man camping. I am.
My little tags.
Yeah.
Rugged man camping. I got a little tradition coming from the military. Every once a year, I go out with my buddies and we go rugged man camping. We go camping in remote locations and go blow some stuff up and have a good time.
I like television. There you go. See, I don't go outside. That's my point. All right, here we go. So, by show of hands, how many people here are actually using AWS Lambda or have used it? All right, I see some, hesitant hands a little bit. Okay, that's good. Good to know. That means we're in the right place to learn. So let's, what are we going to talk about tonight? Well, we're going to go through and introduce what serverless actually is, and we'll talk about Lambda itself, like, how you actually use it, and we'll talk about first applications. There's lots of things you can do with Lambda. One of them is to actually build out application workloads, and I'll do a quick demo of using Python to create a Python web service on Lambda. Which is, I think, a really cool use case. And then Lance is going to go through a whole bunch of much more interesting stuff around how to use Lambda for operations, which we actually do at Reliam a fair amount. And then we'll have some time for questions and stuff. So let's talk about serverless. I actually hate the word serverless because I know that there are servers there, and it bothers me. It's just like, why couldn't they have called it something else? But they did. So let's talk about what it actually means. The contrast to serverless is serverful. And this is kind of it's funny to call this the traditional way of building applications, but it is now. In the cloud world, this is the traditional way, which is that you create servers and you provision them, using infrastructure as code. They can scale up and down using auto-scaling, creating and destroying new servers, vertically and horizontally scaling. But you have to manage those servers, right? They run an operating system. They have software that you have to worry about, like, Apache. I don't know if you pay attention to the world of security, but if you run anything that has Apache or PHP, or there's constantly things to do. Always updates, constant kernel updates, everything under the world to manage.
Or apparently
Intel, yeah, those guys. Thanks for nothing. Yeah, so there's a lot to do, right? You also have to actually manage the resources and monitor, like, this server, how much RAM does it have left? Right? Am I getting close? Am I having pressure there? Do I need to, scale up or down? It's work. Now, AWS gives you amazing tools to do all of this stuff in a fairly automatic way, but it doesn't change the fact that there are still servers for you to manage. So when they talk about serverless, that's what they're saying is less management of servers, right? Not less servers. There actually is probably a whole lot more servers. It's just you don't have to care about it anymore. I think one of the key bullets there is how you're billed and how you pay for consuming AWS services. With a lot of the Amazon services, you pay on a kind of an instance hour basis, or down to the second, really. And what that means is you're actually, as you have a virtual machine running, whether it is an EC2 VM instance that you spun up, Or it could actually be the EC2 instance that's backing your RDS database, or the EC2 instance that's backing one of your other services. You actually end up paying for running that server. You don't necessarily have to manage it, right, if you're using something like RDS, but you're still paying for that service to be there. And that gives you a very low granularity on billing, because the only metric you know is how long have I run the server? Not why, not for what purpose, right? You just know it's running, right? So serverless kind of thinks about things differently. You decompose your application down into functions. And scaling is more continuous and precise. And what I mean by that is you don't have any sort of auto-scaling to do on, I need more servers now, or I need less servers now, right? Scaling up and down. Your functions just get called more frequently. And on the back end, AWS handles provisioning more compute to handle those function calls. And functions are actually executed in response to events and triggers. And we'll get into what that means in a little bit. But function execution can also be parallel. So you don't have to worry about, with a traditional server where you're writing a web service, you have to worry about things like concurrency and handling multiple requests and, configuring your web server or your application container to actually handle that. And I think the most important thing here is actually the granularity of billing. It transforms from instance seconds or hours or whatever into directly into your application. It's based upon the actual execution. So this function ran for this long and was called this many times in response to these events. And when you really think about that, and it gets down to sub-second metering, you can measure that, I think, in milliseconds that you pay. There's a really there's very few pundits, cloud pundits that I actually refer to, because most of the time I just get irritated by them. But Simon is one of these guys that I actually really think is very smart. He quotes, basically said the transition to serverless will be fundamentally driven by, quote, a shift from high to low obscurity of cost. And that sounds boring to probably everyone in the room who's an engineer, but if you've ever dealt with the business side, and you're an engineer and you're like, gosh, I really know that I could refactor this code and it would be so much better. And you go and they come back and it's like, what's the ROI? How many times have we heard that damn phrase? What's the ROI? Well, now you're armed with a very clear way to give them the ROI. You can say, this function in our code, or these sets of functions, are not optimized. And as a result, we're paying this much. If I reduce that function's execution time to do the same thing by 30%, that directly translates into cost savings. So refactoring has financial value, and that hasn't happened before. We will all discover that the crappy function buried in an application costs us money, and the craft itself will improve. It will improve. This is really what serverless is about. People will tell you it's about other things, it's about management, whatever. All of that is really great and interesting, but this is what's the most important. So that's why serverless. So now let's talk about Lambda itself, which is just one of many kind of serverless services out there. There's Google has one, Microsoft has one, there's others out there as well. There's even self-hosted ones that you can run on your own servers, which is weird. Okay, so Lambda supports a variety of different programming languages and execution environments. Java, Node.js, C#, and Python, multiple versions of all of these things. And they can be triggered by a very, very long list of events. So a function gets called as the result, it is required to respond to something happening. So, for example, if an object is uploaded to a bucket in S3, that could trigger a Lambda function. Or if something happens in a DynamoDB table, right, you can create a response in a Lambda function. SNS, SES, CloudWatch, blah, 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 anyway. But the place that I think is most near and dear to my heart, I've been writing web services for a long time and web apps, so I really like, how do I call this thing via HTTP? And you totally can. You have to use the API gateway, though, which is sometimes a bit of a pain. So let's talk about building apps with Lambda. So AWS gives a whole bunch of use cases, and I find it's actually easiest to first talk through, like, what would I actually do with a Lambda function? Why would I do that? And these are straight out of Amazon's like pitch for Lambda. The most classic example you hear is image resizing or image thumbnailing, right? So let's say you're building, a photo sharing site so that you can share data with the Russians, and someone uploads a photo and you store it in a bucket in S3, right? And that photo upload, that file landing, that object landing in a bucket can then trigger automatically a Lambda function that says, hey, a new object has been added to this bucket. You're passed the name of the bucket and you're passed the actual name of the object with the key. You can then fetch that, do a resize to generate maybe a bunch of different sizes of image, or maybe add a watermark. And then boom, you can store it in a different place in a new bucket, and there you go. The entire thing is automatic, right? I need to do this. Before, if you were using a traditional kind of server-full application, someone would upload it, and you would probably, in the place where you're handling the upload, you would do the resizing and do it on the file system, and then upload it, But that's a lot of work to manage and to scale. This is actually really easy. You've got to decompose to a very simple little thing. Something comes in, you do your work, something goes out. I was actually talking to someone over at Disney, and Disney has, I don't know how many of you have been to Disneyland, probably all of you, but they take pictures of you all the time, constantly. They're just snap, taking pictures. And they store all of those, at least last time I talked to them, in S3. And they actually have Lambdas for doing things like watermarking and for resizing and generating different, sizes. But they also have scheduled Lambdas that run that go through and will email you and say, hey, it's been a year since you were at Disneyland, and do you remember these wonderful memories by now, right? But it's genius, right? They just schedule it and off it goes. So it's a really great thing. There's no server, well, there is. They don't have a server in the background that they're managing that has some sort of scheduled task. It's literally, scheduled Lambda. So that's one example. Another one is stream analysis. So this use case they talk about, it's a social media stream, right? So you could load that in through Kinesis, and that could trigger a Lambda, and then you could do things like indexing based upon the popularity of a hashtag in Dynamo. So lots of great use cases there. ETL, this is a very popular one. So something comes in and enters into DynamoDB, like an order, for example, is the use case here. And then a Lambda could then transform the code, or run the code that transforms the data and loads it into a data warehouse for analytics, right? So that's another use case. And the thing I like about this is you're moving a lot of things out of kind of the core path of execution, right? So this is an e-commerce use case, right? Someone places an order on the web. Your number one path of execution that you care about is accepting the money, right? And fulfilling that order comes next, right? And this is moving all of that stuff out of the path, right? It's just saying, look, those other things happen as a side effect of the core kind of path. And that's a common pattern when you're building Lambda-based applications, is thinking about what's your kind of critical path, right? What do I care about most, and what can happen off to the side? That's not to say that the other things can't happen in a Lambda as well, but frequently they do, right? Because they can happen as a response to an event or a trigger. Mobile apps is another good example. So they talk a user posting a status update, and in this use case, they talk about it coming in through the API gateway, right? So this is in response to an event that is happening because a user did something, and their phone sends an HTTP request through the app, and that triggers a Lambda. And then, you can, inside the Lambda, you have access to, for example, I write a lot of Lambdas with Python, and you have the Bodo kind of library, which you can use to talk to all the AWS services, and it all just works. You get the full IAM kind of capabilities where you can restrict and limit what you can and can't do from inside a particular Lambda function, and you can call whatever service you want. So web apps actually is a really interesting use case as well. So this one is talking about a weather app, but this is a little bit repetitive from the last one, so I don't want to bore you. But it's basically the same kind of notion, right? Event causes trigger, causes execution of compute, causes output, and you can actually chain Lambdas together, and you can actually build step functions, as they're called, where you can actually weave them in through a kind of a workflow. All right, so now we're going to talk about kind of an easier use case. Has anyone here written like a Python web service before? Like using Flask or something like that? So a couple of you, okay. There's a lot of existing web apps out there as well written in Python, like tons and tons of them. And it turns out it's actually pretty straightforward to take an existing Python web app and deploy it as a Lambda. So you can then run that web app in a serverless way and only pay when it's running, right? So for a lot of use cases, it's actually pretty great. Saves you a bunch of money. So here's an example of what an actual Lambda looks like in Python. So this is the thumbnail use case that I mentioned. To be fair, I am hiding behind a completely real, I promise, and I totally wrote ImageLib and make thumbnail. Those things totally exist. So just pretend they totally exist. The rest of it is actual real code. So the Lambda here is called handleImage, and it takes in an event in a context. Those objects are basically, you know, the inputs you're getting from the Lambda service to your code. Hey, this is what happened. Now, you know, handle it. In this case, I'm responding to an object being uploaded into a bucket. So you can see I'm pulling the bucket name and the key off of each record in the event. So actually you can bundle these things together if you get a whole bunch of them all at once. That way you're not repeatedly calling the same function over and over again. And then you can see here I'm getting the object using Bodo, and I'm making the thumbnail, and then I'm putting it in a different place, right? Or under a different prefix. And that's it, right? That very, very small amount of code can achieve quite a lot. So that gives you an idea of what a Lambda function looks like. I mentioned before, you can call them via the API gateway, but it's kind of a pain. This is a sort of a common refrain with AWS, like they've built amazing primitives for you to do things with, and they give you all of the flexibility and power in the entire universe, and then it's all, you know, okay, now I just have to write this 36,000 line JSON file that will make it all happen, or call these 2,000 different APIs. So, you know, it's great, but sometimes the barrier there is that kind of, it's difficult to actually realize what you have in mind, what you're trying to accomplish. There are a lot of frameworks out there and such that make life easier, and that's what we're going to talk about now. There's something called Serverless Framework at serverless.com. I really like it. It's actually written in Node.js, which I don't love, but it's great anyway. I'll allow it. There's another one called Zappa that I really like as well, and that one's Python specific. But I wanted to give you something that was a little bit more general purpose. So you can use this with a bunch of different languages. And it actually supports multiple serverless platforms. So you can write essentially the same code or very similar code and deploy it across other cloud providers who also have functions as a service or serverless kind of function services. It's got a pretty big ecosystem, lots of plugins, and one of the great plugins is called Serverless WSGI. WSGI is Python's kind of standard way to low-level create services that can respond to HTTP, right? And Serverless WSGI gives you the ability to deploy any WSGI app, which is basically every framework out there. So Flask and Django and all of them can do this. So I'm going to do a demo real quick, which is always dangerous, but we'll see how it goes. All right, bear with me. I'm going to yell instead of talking to the mic. So I'm going to make sure my text is big enough in my terminal. Is it? Can you guys see? Yeah. You folks, I should say. What did I call the app? Okay, so I'm going to start off with demo app, which is a super minimal, does nothing app, right? Just so you can get a basic idea. And then I'll show you deploying a real app. So this is a simple Flask application. There it is. It returns hello world, right? I'm actually going to quickly add, so you know that I already have this deployed. Let's do, I'm going to create an extra route here.
Now you're getting really dangerous.
Oh man, am I ever. And you're totally not supposed to do it this way, but I don't care. So that's a little app, and I could run this with Flask and run it locally, and it would be bound to a local port, and it would be constantly running and listening, right? But that's no fun. I want to do this serverless. So you can npm install serverless and serverless WSGI, and then you have a little command line tool called serverless, and it has a whole bunch of different things that you can do with it, right? You can invoke them, you can create new ones, you can deploy them, and so on and so forth. What we're going to do is we're going to cat this serverless.yml file, because if you're not YAMLing, you're not clouding. Come on, nobody? This is dead. We need more booze. That's what we need for next time. I'm defining this service, calling it serverless hello. I am telling it that I want the serverless WSGI plugin, and I'm defining the app as app.app. So if you actually look at app.py, which is my app module, there is an object in there called app. I'm saying that's the app. That's the WSGI app, right? I am using AWS as my provider, using Python 3.6, and I'm deploying this in US East 1. Because everybody deploys in US East 1. Why not, right? That's where all the cool kids are. And then functions, I'm actually telling it anything that gets routed to this app through the API gateway, anything, any path that is passed at all, go ahead and pass it to my code. Now the downside to this is that you're routing a lot more than you probably need to be. You can be more explicit, but I'm being lazy here and just saying route it all, right? So then what I can do, I can serverless deploy. All right, now we all cross our fingers and hope that this works. So what it's actually doing is, there's a file that's generated there called requirements.txt, which says, here are all the modules that I need to actually run my application. And the serverless.yml app, our definition says, here's what the application is. It's going to go through, it's going to find all the packages, it's going to download them all, zip them up into a nice zip file. It's going to go into Amazon and create the API gateway. It's going to create the Lambda function. It's going to upload all the code, and then it's going to glue it all together, right? And it does this through CloudFormation and through storing everything in S3. It's pretty slick, and I'm not having to do anything other than just sit here and watch the dots. So there you go. It's uploading the artifacts. Is it going to work? Will we have the most amazing say hello application in the world?
I think Jonathan's probably already got like a little exploit kit up.
Yeah.
You can just pass some plain text.
Yeah, take it down.
I actually do.
Yeah, I did no validation. I was like, you really shouldn't be doing what I'm doing here.
No
But
string validation at all.
it's okay. You can take down my Lambda function. You can own my server, because I don't care. It's not mine.
I hope you put it with administrative privileges.
Yeah, what kind of permissions does that Lambda have?
Shh. When you're actually creating these, while that's going, since it's taking a while. Oh, come on, where am I going? Oh, no, there it went. So I'll show you in a second. So here it is, this beautiful name, just gorgeous, right? You can configure them behind Route 53 to be assigned to something a little bit more palatable. But here's my little service. I call it, and hello world. So if I remember correctly, I had a say hello, and I had a name. So I'm going to put in Jonathan. Come on, where's the thunderous applause? Yay! All right, and before I get completely owned, I'm going to do serverless remove. Oops, server remove. I was getting a little bit after myself. So it's going to go through and remove everything and unprovision it, and it's done. Right? So pretty cool. So while that's going on, I'll show you another app. So one of my buddies, Marty, he creates web services named after characters from Saved by the Bell. Which if you're old like me and you used to watch Saved by the Bell when you come home from school, Screech is one of the characters in Saved by the Bell. And Screech is a podcast publishing web app. So basically, if you have a website that supports publishing, you can go to Screech and it gives you a UI. You can add an MP3 file and then type in what your show is all about, and it'll publish it to your WordPress site or whatever. And it was just like an app out there that I was like, I want to show something that actually works. So it's also a Flask app. So here's my serverless.yml file. Looks exactly the same, except for it's Screech WSGI.application. I did have to create this file, right? Because he didn't have a way to hook into his WSGI app under the hood. But it was really easy. I just basically imported his create app and called it. I actually don't even think I need all this stuff, but I'm not really sure. I don't remember. Okay, so serverless deploy. So again, this is going to take a second. While that's happening, I'm going to show you something else. So I have another service that I'm using. Oh no, is it this one? I think it is. This is an actual app that I use for doing auth. And it's using a method of authentication called IndieAuth. which is kind of sort of like Facebook Connect, except not evil. And open, it's an open standard. And the nice thing about this is, before I had a persistent place where on my server I had an endpoint for indie-auth. Now, it only gets called when it's necessary. I may be auth with different services like once a month. So now my bill goes to basically $0. I think I've never paid for running this service. But the reason I wanted to show you this configuration is that this one actually has IAM roles. So you can actually go in and define on, here's what's allowed. I can do anything I want on this bucket in S3, right? I probably shouldn't be giving it the permission to do anything, right? But it's on a testing bucket, so I feel a little bit better about myself. So that's probably done by now, or no, it's not, because it's being slow. Here it goes, here it goes.
By the way, your other app is vulnerable to reflected cross-site scripting.
It is.
You need to
Yes.
validate your input.
I do. Absolutely always validate your input, kids.
That is correct.
It's very important. Okay, there we go. So if I hit it, hopefully, it'll show up as Screech. Yay, look at that. So it's a client. I can actually sign into my endpoint that we talked about before. So yeah, there we go. I'm indie-authing in. Boom. I logged in, and now I can choose an audio file, upload it, and publish it. It's a real web app. It does the thing. And it's deployed in a serverless manner. So literally the request comes in, the function executes, and then immediately dies after it finishes the request. Lambda will cause what are called cold starts from time to time, so a request may take longer than you want it to. A lot of the frameworks, including Serverless and Zappa, allow you to configure what they call a keep warm kind of feature, where basically it will, every 5 to 10 minutes, just kind of kick it a little bit and be like, hey, stay awake. And you still pay almost nothing, because, again, once every 5 minutes for 15 milliseconds is a lot less than 24 hours a day, 7 days a week, right? So there you go. That is my portion. I'm going to bring this back up and let Lance take over now.
All right, so we wanted to talk about the two main components that Lambda really provides. One is actually running applications, endpoints that you connect to in your web browser. Stuff is rendered and displayed in your browser, applications. The other part of that, it really comes down to infrastructure, and we're talking about using Lambda for automating a lot of your infrastructure actions. And the thing with all of these, with this service and AWS in general, when you really break into it, absolutely everything is an API call. Everything is an API call. When you're creating a server, when you're destroying a server, when you're provisioning other resources and services and taking them down, API calls. And really, when you dive into it, Lambda can do anything that you want it to. And the thing with this service compared to others, a lot of people think of it as a box, and it does this one thing. But it's not a box, it's whatever you can kind of think and dream of. If you have the knowledge to write code in any language that you like, whether it's Python or Node or Java or Go, you can create functions that do something meaningful and useful for your architecture. So I'm going to show you some use cases on the infrastructure side and things that we've actually built and deployed successfully for our own internal projects and use cases, and for our customers as well. So by show of hands, who is using CloudWatch for creating alarms, watching metrics for stuff in your infrastructure? Okay, so as you all probably know, it's very tedious. With CloudWatch, you have to make one single alarm, for every single metric that you want to watch and capture. And that's cool if it's a small environment. You've got a small amount of resources that you're monitoring with CloudWatch. But when you get to a certain point in scale, it's no longer feasible. If you're using infrastructure tools like Terraform or CloudFormation, you actually have to define that and say, I want a CloudWatch monitor to check this metric. And if you have 1,000 of those metrics, you're going to write that same little code snippet 1,000 times. And so we actually use Lambda for automating monitoring. So creating CloudWatch metrics and alarms, and it could be something as simple. In this particular use case, you see two Lambdas on the left and right, and there's a little pool of compute. These are EC2 instances there in the back. And in this specific scenario, we want to create CloudWatch alarms that will initiate a recovery or reboot action. So It's a common thing for EC2 instances to become unhealthy. They may go offline from time to time, and it's actually something that happens just running on AWS, and you're actually supposed to architect around. However, you can use CloudWatch to kind of alleviate that by putting in CloudWatch alarms with actions tied to them. So when this alarm gets triggered, an action is run. In some cases, it can be Lambda functions, it can be other actions. But in this particular use case, what we're doing is having a CloudWatch event, a timer, basically a cron job, every hour, every 2 hours, every 6 hours. You can define this. Run the Lambda on the left and scan all the EC2 instances. In this particular use case, we're using tags and Python with Bodo. So we're basically making Bodo calls saying, describe all my EC2 instances and filter those with a particular tag. Those are the ones that I want to have this automated monitoring. So we're grabbing a bunch of EC2 instances out of the list, finding the ones with the right tag, and then dispatching another API call within the same Lambda to create the monitor. So if you have 1,000 servers, one Lambda function can create 1,000 monitors on your behalf without having to define every single alarm that you need to have. The alternative to that, anytime you're using Lambda to create all this infrastructure programmatically on your behalf, you need to have a follow-up Lambda to do a cleanup. Because resources come and go, instances die, you need to replace them. Everything really should be treated as immutable, so there's always a second Lambda function to go and clean things up. And that's the Lambda function that you see on the right over here. And that's actually scanning everything, and it's seeing if there's actually systems there. It'll check all the alarms and determine if there's still an EC2 instance with that ID still around and available. And if it's not there, it simply deletes it. So it's really programmatically creating all your monitors that you require, and then programmatically removing them when they're no longer valid because the EC2 instance is gone.
It's like your janitor, right?
It's the cleanup crew.
Sweeping up.
Yeah, and so really, it's this is one particular use. As I'm going through the use cases, I want you all to know that what I've kind of diagrammed here is very specific and very particular. This is CloudWatch alarms to do recovery actions if an instance fails a status check, which happens kind of frequently. But this same use case can be applied in many other ways, and that's kind of what I'm saying with the whole box reference. It's whatever you can think of. If you can write a script to do something, you plug that in a Lambda, and you can really do whatever you want on the platform. Automated backup. This is one that we see a lot. If you're running compute, you've got EC2 instances with EBS volumes attached. There's data on these disks that you want to retain. By default, there is no backup. Amazon, they don't hold your hand. They don't automatically back up your systems for you. You actually have to define that yourself. And so you can do it on the system side. You can write your own scripts to execute on servers to back up your applications and databases and all the data components on those disks. Or alternatively, you can use Lambda to basically do disk snapshots, block level snapshots. And in a similar fashion, CloudWatch event timers, can I get a mouse here? These CloudWatch event timers you can schedule for any kind of recurring time. It could be once every 24 hours, once every 6 hours, depending on the importance of the data, how often you want it.
Cron job on steroids.
Yeah, it's just a cron job, and actually you use a cron syntax to define this. It's really just a cron job, but you don't need a compute instance running to have the cron daemon going and ready to go run a job. So in this case, it's similar. We're scanning all EC2 instances with a particular tag that are flagged for backup. Because you might not want to back up instances in an auto-scaling group, because those are stateless. There's no data there worth retaining. The application should be in version control, and database is going to be offloaded onto RDS or somewhere decoupled. Auto-scaling is just purely compute. We don't need to back it up. So we define the instances that we do want to back up with a simple EC2 metadata tag. In this case, we just called it backup. Anything with that backup tag, this Lambda on the left will scan and filter all those instances with that tag, and then read the instance's metadata and see the EBS volumes attached to it, because it's all relational. Everything is referencing each other. By just making describe API calls against an EC2 instance, you can see the EBS volumes attached and how they're all connected. And in the same manner, grabbing those volumes and determining the EBS volumes, the IDs that actually reside there, and making an API call to execute a snapshot against it. And so in this scenario, we're actually retaining EBS snapshots of all the systems we want to capture backups of. And then the janitor function on the right is then going through and cleaning them up. And so in most cases, we do it based on date stamp. So when we take that snapshot, the disk that you see in the back is the backup, the backed up EBS volume, the snapshot. When this process occurs, we actually tag that with a date stamp saying this backup was made on this day. And we actually, in this function, you can reference that. If it's over this date, if it's over a certain time, destroy it. And so you can really set your own kind of granularity to it in terms of what you want to back up, how often, when, what the retention policy should be. It's all very configurable. But this is something that we do kind of by default for all of our customers, and something we've seen out in the wild. A lot of people are doing this same method of backing up data on EBS. Automated documentation. So we recently had a webinar about the well-architected review, and one of the things in there was discussing automated documentation. And this is kind of a new thing. Not a lot of people are familiar with this concept, but it's taking the similar approach in that everything is an API call away. Just by issuing simple describe API calls against your infrastructure and listing all the components, you can basically make your function parse everything that you're running in your infrastructure. Show me all EC2. Show me all EBS, RDS, S3. You can scan all of your infrastructure and really do whatever you want with this data. At Reliant, we actually have a tool that does this. It's an inventory tool. It scans and parses all metadata within an AWS account. It scans all the resources and infrastructure and pulls it into a MySQL database on the back end. And really, once you have the data set, you can do whatever you want with it. You can use ETL jobs and transform that, put it into data warehouses. You can use other tools. I know Lucidchart specifically has functionality in their platform where you execute a script and I haven't looked into the code much. It's magic to me at this point, but it'll actually make an architecture diagram of what your environment looks like. And so if your team is always changing infrastructure and rapidly deploying and evolving, it'll actually keep your architecture diagrams up to date. And so you're not having to go manually log into another service and, okay, I think we moved this here and kind of keep track of these diagrams.
Great for troubleshooting. Like if you're if you're an operator and you're doing 24/7 kind of monitoring, and that's what we do for our customers, nothing is better than having really good, accurate, up-to-date documentation, and the only way you can do that is to automate it, right? If you depend on human beings and meat to make it happen, you will fail. You cannot depend on meat. We are useless.
Yeah, it can really all be defined programmatically into whatever way you want. And that's actually why I listed all these resources in the top there, all the data stores, just avenues of approach, however you want to structure and store this data. It's really kind of up to you. It's all endpoints and API calls. So at this point, I'm going to be honest, I got really sick of writing these architecture diagrams, and so I just listed some other use cases here to discuss them. One is automated response. Is anyone familiar or use the service AWS Systems Manager, SSM? Okay, so SSM, for those who don't know, it's just an AWS service that you run a software agent on a server. It can be on-prem, it could be on AWS or Azure, Google. Just a software agent that checks into this service just kind of constantly is polling. And you can actually issue system-level commands through this service. And they actually, one of the features of this service is being able to get rid of SSH. These protocols. You're no longer having to go connect to a system, connect to a VPN and SSH in somewhere. You can actually just do all that with API calls as well. As long as the system has SSM, the agent installed, you can actually define your own policies, your own shell scripts, your own PowerShell scripts, or whatever it may be. But you can define custom automation on the server side and not only on the AWS infrastructure side, and have that being called programmatically with Lambda. So a Lambda could, in theory, go do a MySQL restart and be interacting with system-level objects but from anywhere else.
So, and good use case for that is like, I was actually talking to a potential customer yesterday, and they were like, yeah, showing us their architecture diagram. We have this fleet of MySQL servers, and it's great and everything, but about every 8 to 10 days, one of the replicas just stops, and we don't know why. And the only thing you can do is just restart it. And they're like too busy to worry about it, whatever. And they literally did exactly this. They have essentially an alarm that goes off. It's a self-managed, MySQL. It's not RDS. Literally, they use a Lambda to basically just go in and kick it.
Right.
Which is like a terrible solution, but it's also,
right.
Kind of works, right? Like, whatever works.
Yeah, in a lot of cases, it really comes down to kind of re-architecting to fix problems like that. But there are still some cases where Lambda could be useful as automated response. In an ideal world, everything is stateless and decoupled, auto-scaling, RDS, and elastic hash, and everything is nice and spread out like that. But in a lot of environments, and especially with larger teams and organizations, there are still standalone systems that are being manually, updated and patched and maintained. It's not an immutable thing where they just redeploy and swap an IP address. So that's still valid in a lot of cases, automated response. And it's such a broad topic. It really depends on the environment and the scenario. I didn't want to diagram that one out because it's so kind of big. But the options are there, and that stuff can be done. We recently had one where there's a pricing constraint. Customer is not willing to pay for us to re-architect the environment and build it up more. And so they have certain systems that just die from time to time. They do some bulk image processing, and the systems basically kernel panic and go offline. Not willing to pay, we have to go respond to the alert every time. Hey, let's just make a Lambda that goes and takes care of it for us. And now we never have to deal with it again. So we've saved ourselves time and money and effort.
And the customer's happy.
Yeah.
The problem's not really solved, but it's solved.
Yeah.
Effectively solved, right?
Right. Cloud governance is one of my favorite ones. Is anyone familiar with this tool specifically, Cloud Custodian? Or other types of governance tools. It's basically defining guardrails for your environment. So if you're working with a team, you can basically establish parameters. If you're launching an EC2 instance, its EBS volumes must be encrypted. If you're doing anything on EC2, you must use M5 large or higher. You can define parameters for all of your infrastructure and all your resources and use Lambda to enforce that. And the enforcement varies depending on the organization. In some places where they're fast and loose and always deploying, if you deploy the wrong thing, it just gets deleted right on the spot, where you're not even allowed to go make something that's outside of the guardrail. In other scenarios, you can alert on this kind of issue happening if somebody's deploying resources that are not within the confines of the organization. Because there's a lot of companies who have rigid compliance requirements. They need to be deploying their infrastructure in a certain way with certain security requirements, certain AMIs, certain network configuration settings, certain security groups. Everything can really be dialed in. And you can write Lambdas to define all of this for you, but there are a lot of good tools in this ecosystem to kind of do that on your behalf. Cloud Custodian is, you write YAML, syntax policies, and define what you want your infrastructure to look like. And it can be executed from the command line, from your shell, or you can also deploy it as a Lambda function, and it'll act on your behalf to go provide this governance for you on your behalf. And the last thing I put in there was a deployment tool. I personally have not done this, but this could be done in theory, since everything is an API call. We do a lot of blue-green type scenarios where production is in the blue little zone, pre-production or not really production is in green, and basically establishing kind of just flips. Those swaps can all be done through Lambda functions, and this This is really specific to the environment, and in most cases there's going to be other tooling that's doing this on your behalf. If you're using other CI services like Jenkins or GitLab, a lot of this can be done through there, but you have the ability to offload any of those components to Lambda. And kind of in a similar fashion, when we're dealing with an application, being able to decouple one particular application functionality and move that into Lambda, you can really accomplish the same thing with anything else. And I wish I had a picture of it, but my favorite diagram for these tools, I see it for a lot of like log ingestion software. It shows the software in the middle, and it shows all these other services and things that it can ingest. And then on the other side, it shows all the other data sources that it can go pipe out to. And Lambda is really the same way. It's whatever you want it to do. It's just an API call away, and if you can write that out in whatever language you like with Amazon's SDKs, you can do whatever you want to on the cloud and automate whatever it is you're trying to do. So I also put in some sample code, and this is for the automated CloudWatch alarm. So this specific function is Python. I'm using Bodo in this case, and then grabbing from the OS library, being able to pull environment variables into the Lambda function. So this, I had to cut off a portion of this, but all this is essentially doing is, one, determine the account number that we're currently working with, and save that as a variable and use it for later. And then I create a function here, create instance alarm, and that's the actual Bodo call that creates the alarm. I don't know if you all can see it, but this is essentially all the attributes required to make an API call using Bodo to create a CloudWatch alarm. It includes the name, the description, the actions that it's doing. And in this case, there's two actions. One of them is a simple workflow that does an instance reboot. The other is an SNS notification to dispatch basically the alarm to SNS to be dispatched if you want to email or webhook or whatever endpoint. And then the dimensions. Basically, this alarm that we're creating with this Bodo function is basically just for failed status checks. And it takes two parameters. One is a Bodo object that you define before the function, because it's only defined once. And the second parameter is the ID of an instance. And so really this one function can be used against any EC2 instance, and it'll go create an alarm for that instance, monitoring status checks. And it will go, if the alarm gets tripped because the EC2 instance has failed a status check, it'll trigger that Lambda and it'll go initiate the stop and start or the reboot. Down below is the actual logic of the function, where we're basically defining, instantiating the Bodo class for the function. And then the second one, we're actually describing all the instances, and this is where the tags come into play. So we're going to describe all the instances and filter every instances with the tag key auto heal. And it could be auto heal true, yes, maybe, I don't care. As long as that tag key is there, it'll go grab that instance. And anything in your EC2 inventory with that tag gets an alarm created for it. That's it.
Hey. We're on time too, so that's good. So we do have time for questions, and there's also more, there's still drinks and pizza and stuff. So first, any questions, anybody?
Serverless versus SAM.
I personally don't have experience with SAM. I only recently found out about it being in the Lambda console and trying to export a function and seeing this other option to export as like a SAM object. But from what I understand, it's just another kind of language that's defining your Lambda function, the resources.
Yeah. On a scale, I talked to some guys and they were saying it's cool, and I started playing with it because it runs API gateways and Lambdas on it.
Right. That's the nice part about it, right? I don't have a ton of experience with it either. So.
One nice thing about Serverless is that it's multi-platform. So with Apache OpenWhisk, etc. SAM is the new kid on the block. Yeah. And yeah, it does the same things, but yeah, it's just.
Yeah. I think the nice thing is it's a pretty emerging kind of ecosystem right now. There's like, serverless is kind of the new hotness, right? And I understand why, right? I think there, we've shown why that's true. But you're going to see tons of different ways, frameworks and ecosystems are going to grow up around it. I was talking to you earlier, right, about Rails, right? You're doing Rails, and we're like, are frameworks all going to die? And it's like, no, but we're going to have a whole new set of frameworks that are going to be about serverless, not about It'll be a different model, right? And another thing that I'll point out is that we didn't mention in the presentation, serverless isn't just about Lambda. They're bringing the concept of serverless to other services within AWS as well, and I actually think that they're going to go this way with everything, right? So if you really think about it, Aurora is a good example of this. They announced at the last reInvent serverless Aurora, right? Which you only pay for the queries that you execute, right? You don't have a backing EC2 instance or multiple EC2 instances that you have to worry about. It's not like RDS where you're paying for it all the time. You're paying for your query execution. Now, I think we're a ways off from that like taking over. And if you actually do the math, it's exceedingly expensive to use Aurora serverless. But I think over time that'll change. And you're going to see more and more of those services. Like I'm shocked they already haven't already announced serverless like Elasticache, for example. Right? Everything will have a serverless version at some point. So you no longer have to be like, this is the EC2 instance size that I want to use to run this thing for me, please. It'll just be, just go, please. Just go.
One thing we didn't mention here is Lambda at Edge, which is really just Lambda, but you hook it into CloudFront. And there's a few different options. It's basically, as requests come into CloudFront and as they leave CloudFront, you can kind of just inject a Lambda in between that and take the input, whatever incoming data, like a JSON blob or whatever, and manipulate it and send it back to the origin or back out to the person. So it's really Lambda. They lock you in. You have to use Node.js for it, but it's another use case of Lambda is actually using Lambda functions on your CDN edges and actually being able to do some kind of programmatic actions.
There is, if you look at the number of regions that Amazon has globally versus the number of edge locations they have, getting that compute out to all of those edge locations, there's a lot more of them, and they're much more globally distributed. So if there is, compute that you need to do that you don't want to have to go back to origin for, doing it at edge can really make a huge dent. We do a lot of that actually for customers.
It's not as robust. There's a lot of limitations. Especially if you're using other third-party libraries, you have to have a really small package. You can't bundle big image processing libraries in your Lambda at Edge functions. It's very lightweight. It's really only string manipulation, basically, kind of moving things around. And it's good for directing stuff to kind of QA or I forget the testing scenario, but basically A/B testing, I think, where basically if sending a GET request to a certain URL, you can just provide a different query string and you'll get a different set of data or like a different render in your browser.
Yeah, and you could do like, if you had content on your website that was like a contact form and you had a sales team in one region and the sales team in another region, you could, based upon at Edge, you could actually transform based on that where the contact information goes or whatever. Lots of different use cases. Any other questions?
Is there a time limit for Lambda functions?
Yes, there is, and you can, so I believe you can configure the time limit, but there is a maximum time that you can configure. And I can't remember either one of those. It's 5 minutes? 5 minutes, okay. Yeah.
For long-running process, let's say the backup takes 30 minutes.
Right.
Is Lambda not the right solution?
Correct. If you're going to take longer than 5 minutes to do it, one thing I will say is I would look at that and have a use case like Fargate, right? So doing kind of short-lived containers and not having to manage a cluster, right? But there are ways that you can chunk jobs out. So a lot of times you actually look at what you're trying to accomplish, and if it's going to take more than 5 minutes, you're like, well, can I break this down into multiple steps? And that's where step functions come in and so on. So.
We do a lot of SQS with Lambda. And so what'll end up happening is you get kind of a small fleet of Lambdas that all tie into each other, and SQS kind of becomes the backbone. So we're basically, one Lambda is responsible for grabbing whatever it is you need and then just putting that into SQS and then it goes away. And then another Lambda will come in and parse, or it'll grab that object from the queue and do something with that. So it's really, it depends on the use case, but you might be able to use SQS to kind of leverage a queue functionality. So you're not just waiting for one single function to go and do all these different steps. just kind of, you can even decouple the lambdas. I mean, we're abstracting abstractions on abstractions.
Yeah, I have to ask on that. Is there a way to get like a webhook in response? Can you just asynchronously say run this function and it says 202, like cool, I'll run that function.
And then I'll come back to you later, basically?
Yeah.
Yes. What you could do is you could have the one Lambda that would trigger the job to happen, right? So let's say if the API gateway you have, here I'm going to post some data that needs a lot of churning, right? And it could immediately return and say, here's your ticket number for this job, right? You would then queue that job, right? That queue could fire off another Lambda, could do the processing, right? And then shove it on another queue, which could then trigger another Lambda that goes out and pings you back via webhook, right? So yes, you could definitely do that. But what you would do is you would build multiple lambdas that are responsible for different stages of that interaction. The first one's job is literally accept and queue the job and return you a ticket number. And then another lambda would do the actual work and then queue the response. And a third lambda would then pull the response off the queue and send it back via webhook to the original caller. So.
Does that answer your question?
Yeah, that was kind of my biggest problem with this long,
because you're
like
waiting.
Running functions, because you can't leave a TCP connection.
Yeah.
Right.
5 minutes.
Yeah. Yeah. It sounds like a use case for queuing whatever action needs to be done on the request.
Amazon often points at step functions.
Yeah.
Okay.
Yeah. And step functions are really kind of Amazon's more codified approach to that problem. Like if you have a sequence of things that need to happen or with several different branches, step functions allow you to essentially define that and all of the, it's nice as well because it gives you a kind of a visual. Maybe we should do a step functions talk at some point. It's pretty cool.
I believe auto scaling uses step functions on the background. I think all the services kind of use each other. Yeah. Any more questions?
All right.
I thought you'd have a hard one for sure.
I did, but I think.
Okay.
Nice. Well, thanks everybody. We've still got the space for another, I think, 20 minutes or so. And there's, like I said, beer and pizza if it's cold, which is the best kind of pizza, and nice people to talk to. So we should do that too. Thanks everybody.